times the derivative of the other. One of the functions times the derivative of the other. And then one of the functions times the derivative of the other, and one of the functions times the derivative of the other. So this is basically like what we learned in Calculus 1, only that a little bit more complicated. Yeah? In Calculus 1, we learned that the derivative of a product is one function times the derivative of the other function plus backwards, right? And so, but this is an extension of that same concept, nothing else. Okay, but this can be shown. Now, of course, there are some nasty things here, like for example, this thing here. We didn't learn this before. Okay, but this is very simple to interpret. This thing here means fx ddx plus fy ddy plus fz ddz. Okay, so this is just what is called a differential operator, because it depends that we have a function on the right on which we operate. So this itself is a vector. So for example, it has three components, gx, gy, gz. So when we consider the component gx of this, we are going to have fx derivative of gx with respect to x plus fy derivative of gx with respect to y plus fz derivative of gx with respect to z, and all that stuff is plus when this is the y component, z component. So this is a huge, long, expression. So it's nice that we have it in this compact form at least. And we have something similar, here the backward term is symmetric. And the other two terms, the second and the fourth, are things that we learned before, because this is just the curl, and once you obtain the curl, you do this vector product, okay? Fine. So we are going to use that known identity, and we are going to apply it to this thing. And you say, okay, fine, if this is complicated, this is going to be even worse. But no, it turns out that there are going to be a lot of simplifications. So let's take a look at that. So, okay, I was going to use that expression there. Yeah. Okay. So, let's say, just to fix idea, that this one is going to be f, the p term, and this whole r minus r prime over r minus r prime cube, let's call that the g one. So we just follow this, okay? And so that expression up here is going to be 1 over 4 pi epsilon 0 times, and we have four terms now. Okay, so the first one, since I call pf, it's going to be p dot gradient, correct? So it's going to be p dot gradient. I'm just changing letters. And what do I write for g? Well, it's going to be r minus r prime cube. Okay. Then the second term, it's going to be, what do I write here? P, exactly. And then vector product, the curl of that mess, right? So it's going to be times the curl of r minus r prime over r minus r prime cube. Okay, so stop here for 1 second in case somebody wants to say that something is not clear. No questions? Good? Okay, so then the next two terms are 0. You see, very easy, because f is p and f is p. So here we have derivatives of p and derivatives of p. But p, what is p? is the dipole moment. It's a constant vector. So any differential derivative that you apply, yeah, because when you apply a curl or a gradient or whatever, you know, derivative you apply to a constant object is going to be 0. So that, for that reason, those two are 0 because you can actually put in your notes because P is constant. Okay, so all right, so that's good. That's not that bad. Okay. Now, second piece of luck. Let's look at this parenthesis, and this is amazingly beautiful. So we don't really need to understand where this comes from. It doesn't matter. But the important thing is the following. Forget about this curl for a moment, and let's just stare at that thing. R minus R prime divided by R minus R prime cube. What does it look like? It's the electric field produced by a charge of value what? No, well, 4 pi epsilon 0, so it cancels out, okay? So clearly, besides the value of the charge and 4 pi epsilon 0, which are constants, what Sean tells me is that this thing is the electric field of a charge located at R prime measured at R. Isn't that the expression of the Coulomb field that we learned before? Right? Okay. So that's one thing. Everybody sees that. Okay, good. Now we need to take the curl of that electric field. What is that? 0, because any electric field has 0 curl. We proved that for any electric field, so in particular for this one. So that's really good luck. And now this is 0. So we are left with this at least single term. Okay? So well, good luck. So let me see here. So that one is P dot, yeah. Okay, so we have still a few minutes to go. So look at the first term, the only one that is left over. In reality, is really simple, because what does it look like, this thing? I showed you before. Well, I showed you with the curve. No, I showed you with the scalar. So this thing here in parentheses looks like px ddx plus py ddy plus pz ddz. What we just did here, I showed you before. So there are 3 terms here. One of them is px derivative with respect to x. Okay, so basically, since px is just a number, for all practical purposes, that first term is nothing but the derivative with respect to x. A simple derivative with respect to x. This object over here depends on x, y, and z. So if I take the derivative with respect to x of something that depends on x, in addition to depending on y, z, so I just can use the multiplication rule considering 2 different objects. I can consider r minus r prime as one function, and then 1 divided by r minus r prime cube as the second function. So I want to look at that thing here as the product of 2 functions, and this is nothing but a regular derivative. So then I can use the calculus 1 rule of multiplication for that reason. Okay? And so, okay, so let's do that. So then the whole thing now, so far, is that we have 1 over 4 pi epsilon 0.
But this is the ratio between minus 1 over 4 pi. Like when you wrote at the beginning, it was minus.
Oh, thank you. I forgot.
Oh.
Yeah. It's really impossible not to forget things here. Well, not impossible, but at least impossible for me. Okay, so we have this, and but that's why I like you. You need to pay attention so we get it right. So okay, so the statement was that because this parenthesis is just a regular derivative, then I'm gonna use the regular calculus 1 rule of the product. And so that looks like this. P dot gradient on r minus r prime divided by r minus r prime cube plus okay, so how do I write this? R minus r prime. Yeah. That's okay. R minus r prime times P dot del over 1 r minus r prime cube. Okay, so let me make sure that there's that agrees with my notes, and then P dot, yeah, and then P dot. But this shouldn't. Just give me one moment. Dot